Watch 3, 2, 1. Action. So guys, so we're starting our new section on statistics and data analysis. Today we're talking about frequency distribution, all right, which is kind of a way of, a lot of these will be visual representations of data, where we'll kind of put data into buckets, all right, where we'll kind of say, like categorize it basically and have a count for the number of items in each bucket, if you want to think about it that way. So there's a whole bunch of different representations of this. So because this is kind of like a vocab and pictorial heavy thing, I don't want you to necessarily draw pictures of all this, but we'll just kind of like verbally talk about this stuff. So this is a line plot where it's counting the frequency of wins for each of these teams, right? And it's just kind of representing with like a little graphic in this case. And you can tell by looking at this, right, if I asked which team had the most Super Bowl wins,
Patriots.
You could see that it was a tie between the Cowboys and 49ers, right? Different things like that. And you can kind of see the frequency at which each team has won over this period of time. All right, so this is called a line plot. So it provides a picture of the statistical data, and each of these kind of graphs may have different benefits at different times. So that's kind of one thing. A similar representation would be a bar graph, where we'd have kind of a vertical axis, and we'd kind of have tick marks representing the different heights of the bars. And instead of having pictures, our bars, would be representing that, and the height of each bar at each spot would be there as well. And then I'll show you also what a back-to-back bar graph is, where you can measure two different facts about the same category. So maybe one bar is representing the number of Super Bowl wins for that team, and maybe the other bar is representing the total points that team scored at, or the average number of points that team scored at those Super Bowls, right? Something like that. So you would be measuring two separate data points, but about the same team or category. So regarding a back-to-back bar graph, so here's one comparing, I believe these are two separate classes, 1980 1997 apparently, and there's a back-to-back bar graph, and you can kind of see that it's comparing similar categories in both of those instances, so I can kind of see that relationship there. Then you can kind of even go even more advanced. So here's a three-dimensional bar graph where I've got, I'm sorting by manufacturer, I'm sorting by year, and I'm sorting by, number of car sales in thousands. So that's obviously a little bit harder to read. For instance, like this pink bar in this, middle column here. I would kind of have a hard time figuring out exactly what that measures up to. So I don't know. That's kind of like just fancy looking, but I guess not very functional. That's probably what I'd say. And then what we're going to get into today is 1,400. Yeah, it's probably around there. But if I measured straight across, I might have misinterpreted it as being around 2,000, right? But I agree that technically this is kind of like sloping down, so I'd have to account for that as well. Because it does appear to be shorter than this blue one, and this blue one is less than 2,000, right? So yeah, the interpretation there is a little bit weak as far as that goes. Now, what we're going to spend most of our time on today is frequency distribution, all right? And there's going to be a lot of different little vocab words here that we'll have to practice and make sure we're familiar with. Basically, it's the same idea where I kind of categorize within certain ranges of data. So let's see. So in this case, this is retail management testing scores. And I've got the number of people that scored between 60 and 70, 70 and 80, 80, 90, 90 and 100. And I then just have the count of the number of people that got the score in that range. Okay? So to determine the number of classes, all right, that's what these separate buckets or groups are. Those are called classes. What we can do is find the range, which what is the range of a set of data? Does anyone know? It's right up there. Right, the difference between the highest and the lowest. So the range here is probably somewhere between It's probably about 40, 100 minus 60. I don't know if that's actually the range or not. But then once I find the range, I'll then want to kind of break it up into intervals that are somewhat meaningful to that range. I obviously wouldn't want to just have an interval that was from 60 to 100, because then it just would lump all my data into one, and that's not actually giving me any valuable information. I also might not want to break it up into 60 to 61 and 61 to 62 and 62 to 63, because that's not necessarily helpful either if each of my categories then only has at most one point in it. I kind of want to have it not so gradiently detailed that I end up having no valuable information on it from that side either. So regarding these classes, the class interval is the range of each class. And a very important distinction here, not all, data sources or publications use this exact format, but at least for us, if I talk about a class of 60 to 70, I'm referring to that as being equal or greater than 60, but less than and not inclusive of 70. All right, so if I had a score of exactly 70, I would count it in the 70 to 80s class rather than the 60 to 70s class. All right, so just so you understand that the inclusive is on the lower number and not the upper number. All right, and now if I refer to the class interval, it is the range of each class. So what do you think the class interval in this case would be? What are the class intervals there? 10, right? The range of each of those classes, I broke it up into spaces of 10. And if I'm doing kind of a proper frequency distribution, all right, where frequency, right, think about actually the word frequency, how frequently your data lands in this category. All right, so think about frequency as that. And then distribution, I'm distributing my data into these separate categories and finding out how frequently my data lands in those specific classes. So the range here is 10. So that kind of breaks that up there. Let's see, the next term is the class limits, which this says the class limits of a set of data organized in a frequency distribution are the upper and lower values in each interval. All right, so the class limits here would be 60 and 70. Okay? Right, the class limits for this one are 80 and 90. Right, so limits, think boundaries, right? Speed limit, you're not supposed to go faster than that. That's the limit, right? Also, by Brattleboro, we have a minimum speed limit, right? I think it's 45 miles per hour on Route 91, right? They don't want you driving 30 miles an hour on the highway. That'd be dangerous for everyone else that's trying to drive past you. Actually, that's one of the things I want to mention about class intervals. Notice the class interval is the same for all of these. All right, so for this to be a proper frequency distribution, I shouldn't have one be 60 to 70 and then another be 70 to 100, right? I should have it kind of be increments that are counting by the same amount. And then the class marks, now that I know what the class limits are, the class marks are just the midpoint of those limits. So what would the class mark of the 60-70 range be? Right, 65 is just the midpoint, right? So I can find that by adding my limits together and dividing by 2. All right, so I just want to point that out. We've just had 3 vocab words. Class interval, all right, is referring to...
Wait, why isn't the limit 69 and the middle would be 70?
Well, because I could have 69.9999, anything up to 70 would be included. So I agree, is that really the midpoint? I see kind of your argument there, but in this case, yeah, we just take the class mark is the midpoint of it. So yeah, I just want to point out that so we've had 3 vocab words that are all similar. Class interval is the range of a class. The class limit were kind of the boundaries of the class. The class mark, M, I guess would make me think midpoint. Okay, and then once I have that information into a frequency distribution, which is a table, I can graphically represent it in a histogram, where I make a bar graph where the width of each bar represents the interval and the height of each bar represents the frequency. And I'll just show you a quick picture of what that looks like, and then we'll take a break because it's just about lunch. So here is a frequency distribution, right? So here's my frequencies, and here is a histogram. So the bar's width has to be the full width of the class, okay? So that's why a histogram is slightly different than a bar graph from what we get there. All right, so I think we're all set. Have a good lunch.